Good afternoon, everybody. Welcome to the reproductive system. I should say hi, because I don't know if it's morning, afternoon, or evening, really, where you are. But welcome to the reproductive system. This is our last organ system. We are in chapter 27. So we're going to be talking about the male and female reproductive systems in this chapter. And then in our last chapter, we'll talk about the growth and development of the fetus, labor and delivery, and we'll finish off talking a little about genetics, okay? So in this chapter, the reproductive system, we're looking at a form of reproduction known as biparental reproduction, where each parent gives something to produce one single offspring. The offspring that we produce is not genetically identical to either parent. The thing that we're giving are called gametes. These are sex cells. Males produce motile sex cells known as sperm. Females produce non-motile sex cells called eggs or oocytes. And when the sperm and egg come together, we produce what we call a zygote, which is a single-celled organism that will eventually become the trillion-celled human. So males and females both contain gonads. Gonads are the primary sex organs. For females, the gonads are the ovaries. For males, the gonads are the testes. The gonads produce the gametes, either eggs or sperm, but they also produce large amounts of sex hormones. Sex hormones are hormones that stimulate both the production of those sex cells, but also they stimulate secondary sexual characteristics. Then both males and females also have secondary sexual organs. For the male, we have a duct system, and in the female, we have a duct system. Males have specific glands that help to produce the semen, and males have a penis that delivers sperm to the female. Females then have their own duct system. They have a uterus that harbors the growing fetus, and then their organ of copulation is the vagina. Females also have breasts, which we'll talk about. Breasts are discussed in both. Actually, they can be discussed in the endocrine and in the reproductive system. In this system, we're looking at the breast as the organ that feeds the neonate when born. And copulation is what unites the two gametes, the sperm and the egg. So we're born with either male or female organs, but we don't have many differences at birth. These differences actually start to show up at puberty. So the hypothalamus is releasing a hormone called gonadotropic releasing hormone. This gonadotropic releasing hormone stimulates the testes and the ovaries to start producing sperm and egg. Prior to puberty, the hypothalamus is very sensitive to testosterone and estrogen, and so follicle stimulating hormone, luteinizing hormone, they stimulate the production of the sperm and egg, but they also stimulate the release of hormones. And so testosterone and estrogen are released, and they inhibit gonadotropic releasing hormone. And so this occurs up until about puberty. At puberty, the sensitivity of the hypothalamus to testosterone and estrogen decreases. And so the increase in testosterone or estrogen in the system doesn't seem to do the same thing. And that actually allows follicle stimulating hormone to activate spermatogenesis in males, or follicle stimulating hormone to activate folliculogenesis, where we activate the follicles and then oogenesis follows, to produce our sperm or egg. Testosterone and estrogen also will stimulate the secondary sexual characteristic formation in both males and females. So in males, a male will get broader shoulders, they will get larger muscles, their voice will lower, they will have more hair growth on their face. In females, breast development occurs, hips broaden. In both cases, we'll have pubic hair and axillary hair form. So now we're going to get into the male reproductive system. The male reproductive system has multiple structures. Looks like it's relatively easy. The female reproductive system is a little bit more complex, only in the fact that in females we have to go through a process of oogenesis, which is different from normal gametogenesis, which is what we typically talk about in like Gen Bio. So we'll talk about the males first, and then we'll talk about the females. So the males' organ, or their primary sex organ, are the testicles. Testicles are found in a sac called the scrotum. From there, we have a duct system that includes the epididymis, the ductus deferens, and the urethra. We have multiple secondary structures that help in production of semen: seminal vesicles, prostate gland, and bulbourethral gland. And then the organ of copulation is the penis. The major function of the male reproductive system is to produce sperm and transport that sperm to the female reproductive tract. So over here you can see, you see the scrotum and the penis. You see the inside the scrotum is the testicle. Then you can see from here, we have this thing called the epididymis. There's this tube here that's called the ductus deferens, or the vas deferens. Ends in this ampulla, which then leads to an ejaculatory duct. The ejaculatory duct actually gets secretions from the seminal vesicle as well as from the ampulla of the ductus deferens. These both lead into the urethra. From there, we have secretions from the bulbourethral gland and secretions from the prostate gland that move in to and follow with the sperm, forming the full semen. And then there's that penis, which is the organ of copulation. So let's look at the scrotum first. The scrotum is a skin-covered sac that hangs outside of the body. The function of the scrotum is to allow the testicles to hang outside the body. So sperm have to be produced in a cooler temperature than body temperature. And so this allows sperm to be produced easier. The testicles that are in the scrotum are on either side of this raphe, which is this like little tiny ridge. And it kind of separates each of the testicles. So if something happens to one testicle, it doesn't always lead to damage to the other testicle. There are two smooth muscles, that's what I should say, that surround the testicles. We have the cremaster muscle, which is a muscle that leads from the abdominal wall all the way down. This cremaster muscle surrounds each testicle individually. And then surrounding the edge of the testicular sac, the scrotal sac, is the dartos muscle. These two muscles together help to control where the testes sit in relation to the body. So if the environment gets very, very cold, sperm aren't going to be able to be produced as effectively, and that's going to cause these muscles to constrict or contract and pull the testicles towards the body to keep them warmer. If the environment is very warm, these muscles are going to relax and allow the testicles to hang lower. And I just mentioned this. So you can see the cremaster muscle is kind of a muscle that surrounds each testicle, kind of like a testicle is inside of a cremaster sac, muscle sac. And then the dartos muscle actually surrounds the edges or the walls of the actual scrotal sac itself. If you look at the cremaster muscle over here, if we cut away the cremaster muscle, you can see that the entire structure is known as a spermatic cord as we move up. And so there's blood vessels, there's nerves, all moving in this area. And then you have that ductus deferens right here that all run through in that cremaster muscle. Okay, I'm going to stop this video because it's been 11 minutes, and I'll get into the testicles in the next video. Bye.